Hello, good day to you. You're once again welcome to MS Constructions, where we discuss all things engineering, architecture, and 3D modeling. Today, we'll be learning in Protastructure how to manually design your beams. And why is this important? It's really important because manually designing your beam to make your design to be practicable based on what is obtainable in your area, because sometimes it might not just be you interpreting this design. It might be, local artisans that you have to work with. It might also be some other engineers. And it's very, very important that whatever you're designing is as relatable as possible so that what you have designed will be what will be transferred into the reality. Now, we have this design right here, and as you can see, I've actually activated my design status, and I have the design status indicating that everything here is okay. So which means my beams are also okay. This is after I've done the automatic design. The Protastructure software has done the design for me, and it has labeled every of my structural members okay. So you can go to review. This is your design status. Click on this to see your design status, and everything is okay. But because it's okay here doesn't mean everything is really okay. So what I'll first go and do here is to check my columns. You can see all columns are actually okay right here. So what I want to do is I want to go back to my analysis. Then in video analysis, I'll go to post analysis. Then I'll check column wall design to see all my designs and make sure that what I have here with my steel bars is very, very practicable, because sometimes it can come with designs that are not really practicable. Like you can be seeing something like, let's say 6y16, when you can actually have an economical 4y16. It can come with 8y16, even when in reality you can have just 6y16 sufficient for your reinforcement design. And this is where you juxtapose what you have here with what your design status also says, because when you manually design, it will let you know whether what you have designed is okay or not. The beam is actually the focus of this. Everything is okay with our column, so we don't really need to work on our column. 5y16 is okay at 175 spacing for the links, which is y10, and you have the utilization ratios here. So now let's close this and go to our beam reinforcement design. Now when you go to this interactive design for the first one, you see exactly what I'm trying to say here. Because I've corrected this, you realize that what we have here is that we have for the top bar, you have 2y16, and you have this support bar that is supporting the top bar, 1y16, and you have the bottom bar to be 3y16, and this top bar actually overlaps. This also, doesn't overlap. So let me go here and go and look for the one that is not okay so that we can work on it. Like this one now is really, really very complicated. Now for this one, you see that you have 2y50 here, which doesn't seem right. Y50 is not supposed to be part of what we designed, but for some reasons it's here, which is terrible. And you can see that while the design is okay, you realize that this is actually going to be a disaster, an economic disaster to include in your design. And that's why it's always advisable for you to manually design your beams. After the software has done all the analysis and the designs for you, you need to come here to manually design every single beam, and that's what we're going to do now. So what I want to do here, I have 2y16 here, and when you look at this 2y16, look at the properties, you see that it's cranked on the right and also extended to short, and that's what you have here, which means the bar stops somewhere around here, and then you now have the support bar spanning from here to here. This is usually a ratio of, I think, L/3, the length of this place over 3 and the length of this place over. Then you now have this bar continuing to short, because this bar is not supposed to actually lap inside this place. Most of the time you don't lap top bar in the support because of the hugging moment. So, and when you lap top bar inside the support, what usually happens is that it becomes a weak spot for hugging moment. That's why you have the design here. But I don't really want this design like this, because when you look at the length of a bar, the length of a bar where I come from is around 12 meters, which is around 12,000 millimeters, and a single bar can actually run through this. So if a single bar can actually run through this, what do I need to do? I need to just go here and change from this extend right to short to extend right to lap. But what this extend right to lap means It's not as if we are lapping at this support. We are not lapping at this support. What is just happening is that we are extending a single bar to run through the support. So which means the bar is not ending here. The bar is continuous. So, and I'm going to actually let you see what it looks like. So this is 1C5, 1C7, 1C8, 1C11. So let's just go and look at the design right here to see what it looks like. So we can go to join and reports to look at the story beams. So we have story beams here now. So let's go here just for story 1 to see what it looks like, so that when we now redesign, you now see what it looks like again. That's finished reading, so we can check it out. So that's 1B12, 1B5. This is it. This is what the design looks like. You have the top bar going from here, then you have it cranked right here, then you have it stopping here, then you now have the other bar starting from here and then ending somewhere around here. Then you now have the other support bar that is under, which is 3Y16. And what I'm trying to do is that instead of having these bars like this that are a little bit complicated, we can easily have a straight bar just running through this, and it will be very okay. Like the design will be okay, the design will give us the same results. So that's what we actually want to achieve. So let's go back and try to see what we can do, differently, and we'll now come back to check this design. Just look at what this design looks like now, and when we come back, you see what it's going to be like after we have manually designed our beam. So let's go to post analysis, beam reinforcement. Let's go to this. I'm going to remove this and change it to 16. And you see that when I change it to 16, you have this, which is trying to tell us that the area of steel supplied as this mid span is less than what is required. And you can see the minimum of what is required. What is required actually 595.18, and we have minus 193 here, which means what we have here is 193 less of what is here. So which means you have to increase this to like 3Y16. And once we increase it to 3Y16, you see that it's already above this 595.18 millimeters squared by 8.01. So that's what this means. I don't usually like to crank my beams because most of the time, in Nigeria we don't usually crank, but you can actually choose to crank, but I'm just not very used to crank unless it's absolutely necessary. Then I'll crank the beam. So now what I want to do here is I want to extend it to lap. I see when I extend it to lap, it goes from here and goes into the support. And in this design, actually, it's going to show like it's lapping. But in the reality, it's not actually showing that it's lapping. What you just have is you have 2Y16 extending from here down to here, down straight to here. And that's what I want to actually achieve. So now I'm going to remove the crank at the end. I don't want cranking. But this is just a personal preference for my design. I want my design to be as simple and as interpretable as possible, and as also practicable as possible. So now I can remove this cranking from both ends for this one. Then I'll also extend to lap to the right, extend to lap to the left. And when I do that, you see that my design is still very, very much okay. But when I come down here, you see that I'm having a little bit of problem with my links here, because my links here are insufficient. It's telling me that the S bars here at the top is 18.75, and that's because here I have too many bars here. So which means what I need to do is I need to remove some bars here, because when you lap this, it means that at this support you're already having 2Y16, and you're also having this 3Y16, then you're having another 2Y16, which is going to be too much reinforcement. So instead of me just leaving it like this or adjusting the link, the diameter of the link or something, what I can just do is to be economic with my design and then turn off this, because this is 2Y16 and we have 3Y16, and realize that what we just need here is around 5Y16, because that's what was there before. So if we remove this one completely, it's still going to be okay. And we can also reduce this. Oh no, we can't reduce this. So we have this at the top. So what we can do is that we can reduce this, you understand? Then we can make this to be 3. Then we can make this also to be 3. So now you'll notice that even after we have edited this, we still have this. And in order to clear this, we can actually rearrange the positioning of this bar, and you can do that by going here and changing that from bar layer 1 to bar layer 2, which means you are moving it a little bit down. You understand? And once you change it to bar layer 2, you see that you no longer have this, and we have everything here to be cleared. Why some people actually choose to ignore this, I think anything that is painted red shouldn't be ignored. It should be attended to, that's why it's there. Because the spacing at the top between bars and the spacing at the bottom between bars is very important. The most important thing here that you need to watch out for is deflection check. And deflection check is so important because it's what will make you to know whether your beam is actually going to fail outrightly or your beam is actually going to stand to be effective in carrying the load that's decomposed on it from the slab. And you have L over D here to be 12.29, which is less than 35.03, and here to the same thing less than, and here to the same thing. You see that it's also painted black, it's not painted red, so which means that it's okay. So now when we come here, you see that we can do the same thing here as well. To adjust this, we can just turn this to 2x16 also, because it's possible that the same thing that we'll do here is what will be required here. Then let's remove cranking. I remove cranking from here, then I lap this, extend left to lap, then I remove crank again, then I go here to remove this completely, then I come here actually to turn this down, and you see that I have the same thing here. So what I just need to do is to just click on this bar and then put this on layer 2, and once I do that, you have everything here to be cleared. So now we can go back to check the design, press OK to save whatever you have done. You need to turn this down to 2x16 or 3x16 because that's what we have here. Sometimes it doesn't really follow that what you have here is what you have here, but most of the time usually works like what you have here is what you have here, but every beam is carrying a different load, and most of the time it doesn't actually really follow that what you have on one span is what you also have on the other span. So just like we have this 2x16 right here, but if you want to actually make it for economic purposes, you're just going to be running one straight beam, you can just turn this to 3x16 so that you have a straight beam running through, which is very advisable. You have just 3x16 running through, and you see that when you do that, everything you have here is still okay. The ability to manually design your beams is very important, and you should also be able to manually calculate when it's necessary. Why this might be economical practicably by design, you already know that you're already using more than what is required here. 2x16 is actually enough. Instead of going through our report after we have saved this, we can just go here to detail drawing to see what it looks like. And when you click on that, it will bring out the detailed drawing of this particular beam, and you can view it for what it is. We already have this beam, this 3x16, and it's running all through. Unlike what we had before, is running all through to the end, and that is what we want. So now this other bar, which is 2y16, is the support bar that we introduced and we put on the layer 2, and this bar also runs at the support, and you have it here at 1400. And when you look at this illustration compared to the other one, it's a lot simpler. It's a lot easier to translate this into the real world, into what you have on your site. It's a lot easier, and it's economical, and it's also more practicable. But if you don't really know how to manually design your beams, you're going to just be designing what people will just see and not be able to translate. Especially if the default design of the Protastructure software is not what is obtainable in your geographical location. So now we have the bottom to be just 3x16, and this 3x16 is also running through. Somewhere around here we have a change of diameter, and you see that you still have your 3y16 and you have your 2y16 running there. So you have section BB. Here you're going to be having 3y16 up and 3y16 down. And that's what you have here, 3y16 up, 3y16 down. That's section BB1. Section BB2, cutting it, you have also 3y16, 3y16. At this support now, you have BB3, you have 3y16 up, which is the straight bar that goes straight down. Then you also have 3y16 down. Then you have this support bar here, which is 2y16. As you can see, it's labeled T2, which is top 2. And when you look at it here, you see the illustration of how the reinforcement is going to be installed in your bin, and you see it here. So you have this 1, 2, 3 here. Then after the 1, 2, 3, then you install this right under it. So their bars are meant to support these main bars. These are the main bars, the main top bars, and you have the bottom bars here. So these bars are just going to be supporting these bars, and you have them at the edge as shown and as depicted here. You also have to understand that they are going to be from the center line of the column that is supporting them. They're going to be 1400 away from this side, 1400 away from that side. So you have L over 3 here and L over 3 here. And the thing is that it's just a provision of support, but it's not slapping. So, but at the end of the day, when you are providing it, this is what you need to work with as length of the bar. It's just more like when you are providing a top bar for your reinforcement, to support the main reinforcement and to provide the resistance against hugging moment and all that. And that's just something like that here. If you are supporting at the bottom, you can actually lap at the support for bottom bars, and most of the time it's usually very advisable if you want to lap top bars to lap at the mid span, not at the support. The mid span is where you don't have much going on for top bars, and the support is where you have the most going on for top bars. And when you look at your bending moment diagram, it usually goes something like this, and then you have it coming up here, then you go like, which means at the bottom you have more sagging moment. Propensity for more sagging moment occurs at the middle of the bottom bar, where propensity for hugging moment occurs at the support for the top bar. So that's why you need a stronger top bar at the support, and you need a stronger bottom bar at the mid span. So now, having finished this, we can proceed to do this. And as you can see here, we also have the same thing here. We have 2y16 as the support bar for the top main reinforcement, which is this, and you have it also lapping to the right by 1400 and to the left also by 1400 from the center of the support, which is going to be the column. And you also have the bottom bar to be 3y16 and the top bar to also be 3y16. And it's not really much different from what you have here, just like we designed what we designed here. You see that this bar is running through, and when the bar gets here, there is some sort of lapping here, but in the real sense we are not going to be lapping here. It's just going to be a straight bar that runs through from here down to here. If we cut a section around here, it's going to be 3y16 for the top, and you have 3y16 for the bottom. Then you now have this extra support bar here, which is 2y16. And I think we are done with this, and we can go on ahead to consider another example for our reinforcement. And you can press OK to save. Then you can go on ahead. Let's go to this. And when you look at this, you see that this is the original design. When you go to the drawing details, you see that you have this bar like this, having 2y16 for the top main bar, and you see it cranked here, and you have a top one here, which is 3y16, and you have another top 2 here, which is 2y16. And why this main bar stops here, it doesn't go into the support. So the bar coming from here also, which is the main bar, doesn't go into the support, but rather you have this top bar spanning, that's 1400 away, which is by calculation supposed to be around L over 3 or 0.3 L. And here you also have L over 3 from the support. It's L over 3 here, and it's also L over 3 here. Then you also have the T2, which is going to be at 900 away from the center line of the support, and you have that here also. But we don't really want this design. What we want is we want a beam to just run through this. So you can have your 2y16 or 3y16 running through this, then you provide a support bar for the top reinforcement. And you also have your bottom bar, and as you can see, this bottom bar actually just runs through without any interruption. So we can go on to do that. The one that runs, you see that it's written here, extend right to lap. So that's just what we're going to do, but I'm going to just remove the crank here. I don't want cranking, and that's what usually happens when you extend to lap. It just takes a single beam and runs it through. So no cranking here. So I want to extend this one to lap instead of to short. Now extend this also left to, is right to lap already, so I'm extending it left to lap, and I'll remove the cranking, and I'll remove this completely. Then I take this and turn it down. You realize that we still have this here, which is the span at the top, to be giving us red, and I'm not going to ignore it. I'm going to just fix it by taking this bar and changing the layer from layer 1 to layer 2. So it's not going to be at the top, it's going to just be like a side bar, a support bar on the side, and you're going to see what it looks like in the diagram when we go there. When we go there, you see that we have this bar running straight, then you have this also running straight, and that's exactly what we want. Then we have this support bar here, you know, spanning 1400, 1400, that's L over 3, L over 3. Then you have the diagram here to be 2y16, 2y16 for this first section. For the second section, 2y16, 2y16. Then for the last section, you see that we have 2y16 at the top, 2y16 at the bottom. Then we have this support bar here, which is, you know, supporting the top bar right here. And that's it. So I think we are good with this, and we can save by pressing OK, and you can close this and go back to your 3D interface. This is it for today on how to manually design your beams in Protastructure, and also how to adjust the design that the Protastructure software has done for you to achieve not just a more economic design, but also a practicable design. Don't forget to subscribe to our channel for more videos like this, and you can hit your notification bell to be first to see our latest videos. Thanks for watching, and bye for now.